Good day, ladies and gentlemen. Today we'll be dealing with the topic application of coordinate geometry and matrix to area of triangles and quadrilaterals. So we want to look at the relationship between matrix and coordinate geometry and how they apply together. So we'll be working with triangles and quadrilaterals. So we have a question here. We have to find the area of a quadrilateral with the following vertex: 1, 1, 3, 4, 5, -2, and 4, 7. Please, we need to understand that each of these coordinates or these points, they are in order of x, y. X, y. So that means the first number here is for x. So this is x1, x2, x3, x4. And here will be y1, y2, y3, y4. So having known that, let us draw a sketch of this coordinate or this graph. Let's present a sketch of the graph. So here is going to be our y-axis rather, sorry. Here is going to be our y-axis and this will be our x-axis. And for the x-axis, the highest number we have for the x is 5 because this is x1, 2, 3, and 4. So the highest number is 5. So let our scaling range from 0, 1, 2, 3, 4, and 5. While the range of value for our y is 1, 4, then we have -2 and -7. So let us have it as from 0, then, okay, I will just take it at random. Let this be 2, let this be 4, and let this be 6. Here we have okay, let me adjust it. Here 1, I want the board to contain it. Here 2, 3, -1, -2, -3, -4, -5, -6, and -7. Okay, good. Now, let's find the position of each of these points on the graph. When our x is 1, y is also 1. So let this position be 1. So we trace this like this. And when x is 3, y is 4. 3, y is 4. When x is 5, y is -2. And when x is 4, y is -7. Something like this. So we can join the points together like this. So we have a quadrilateral. This is not a perfect graph, but we can manage it. So we're supposed to have a quadrilateral that, let me adjust this point. So that should look like this. Something that looks like this. Good. Alright. Please note that the relationship that links this geometry and matrix together is in this order. If we have x1, y1, and x2, y2, x3, y3, the area of this triangle is given as half of this formula where we have 1 of x1, y1, 1 of x2, y2, then 1 of x3, y3. So they are expressed in a matrix form like this. And from what we have here, triangles where this one will be triangle 1 and this place is triangle 2. So from triangle 1, our coordinate is 1, 1. Then on this point we have, here we have 4, minus 7. Here we have 3, 4. And here we have, what is the last one? Here we have 5, minus 2. Okay, with what we have here now, we can now represent the coordinate that form these triangles into that matrix form. For the first triangle, we are going to have, let's start from here. We are going to have 1, then 1, 1. This 1/2, then 1 into, the next one is 4 minus 7, and this one is 1 into 3, 4. Then, that is for the first triangle. Then for the second triangle, we are going to have, we are going to look at these coordinates. This, and this. For the second triangle, this one, and this one. So we are going to have 1/2 of 1 into 4 minus 7, 1 into 5 minus 2, and 1 into 3, 4. Alright, having had this, we are going to now find the determinant of the matrix. We find the determinant of the matrix by multiplying, taking the row and the column out from the expression. So we're going to have 1/2. Starting from here, this will be 1. Then we leave this column and this row. We form a 2 by 2 matrix from here. This will be 4 times 4, which is 16. Then minus 7 times 3 will give us minus 21. So this will become plus 21. Then please note that this is plus, minus, plus. So this will be minus 1. Then we open the bracket. We leave this column and this row. We multiply this one and this one together. So 1 times 4 will give us 4. Minus 1 times 3 will give us 3. Then we come to the next column. We have plus 1. Form 2 by 2 matrix from this. 1 times minus 7 give us minus 7. Minus 4 times 1, which will give us 4. Close the bracket. Plus, then we come to the second matrix. Plus, we come to the second matrix, which is 1/2. Leave this row and this column and this row. This is the column, this is the row. We leave this row and column. Then we start from 1 here. Multiply by 5 times 4, which is 20. And minus 2 times 3 is minus 6. So this, since we have minus 6 times minus times minus 6 will become plus 6 here. Then minus 1. 4 times 4 will give us 16. And minus 7 times 3 will give us minus 21. So here we have plus 21. Then plus 1. We have 4 times minus 2 is minus 8. And minus 7 times 5 is minus 35. So this one will become plus 35. So let's solve the first part of this row, and we're going to have 1/2. 1/2. 16 plus 21, that is 37. Minus, times 1 is 37. So minus 4 minus 3 is 1. Times minus 1 is minus 1. And minus 7 minus 4 is minus 11. Times 1 will give us minus 11. Plus 1/2 which is 35 minus 8 will give us 27 times 1, that is plus 27. Alright. The next thing is 1 over 2. 37 minus 1 is 36, and 36 minus 11 will give us 25 times 25 plus 1 over 2. Then we have 26 minus 37. That is minus 11 plus 27. It will give us plus 16 times 16 here. So, if we have 1 over 2 times 25 will give us 25 over 2 plus 16 over 2. So, finally the SN we have 16. So, 25 plus 16. 25 plus 16 will give us 41. Let me write it. So, we have 41 over 2. And the area of the shape will give us 20.5. 20.5 square units. The square unit of what we have there. So depending on the units given. So this is the simple way of solving problems that have to do with coordinate geometry and metrics. And I hope you all understand and enjoy the class. Please endeavor to follow us and share our videos from time to time. Thank you. Have a wonderful day.